Last video for this week, we just do an old AP question, even though I guess you seniors probably won't experience this. This was kind of a lock, a question like this, to be on the AP exam if you got to take it in the past format. But in the current format, obviously, or hopefully, there was nothing like this on the AP exam because they said there wouldn't be. So we're just going to look at one of these net change type of AP questions and then just call it a day. So how much sand will the tide remove from the beach during this 6-hour period is the first question. They give you a story about sand and that the tide is eroding sand given at a rate given by this R of t function, but they're putting sand back on the beach modeled by this S of t function, and at t equals 0, there happen to be like 2,500 cubic yards of sand on the beach. But anyway, let's just get to it. We want to know how much sand will the tide remove. The key things is these are rates of change already. So if you want to find how much sand was removed, just integrate the rate at which the sand is being removed. Just integrate the R of t function and just do it, and whatever you get, you get. You do not have to actually write 2 plus 5 sine of 4 pi t over 25 thing here. You can just, if you're going to do the integral in your calculator, which is how I recommend you do this one, you just need to just type this thing in, get the answer, done. But I already know what R of t is, so you can just write the name of the function. You don't have to write the rule/equation for it. And if you just do this in your calculator, again, it's a trig thing, so you need to be in radian mode here. You should get 31.816, and that's in cubic yards. So the way you can kind of tell if you're ever not sure is what is t measured in. T is measured in hours, so that means dt is also measured in hours. R of t is the rate, and this is cubic yards per hour. So if you multiply cubic yards per hour with hours, you should get back cubic yards. That's kind of really the reason I cared so much about the dx, dt, du, and all those antiderivatives we did in the past. So anyway, that's it for part A. Part B is kind of weird, and it says, write an expression for y of t, the total number of cubic yards of sand on the beach at any time t. So we're going to say y of t equals, key thing is we started with 2,500 cubic yards of sand. So this is just 2,500, and then sand is getting eroded at this rate. We're not going to subtract R of t, because R of t is how fast the sand is going away. We want to integrate R of t to see how much sand has gone away. So you want to subtract the integral from 0 to some time of the R of t function. But then you need to add back the fact that they're adding sand, so we're going to say plus 0 to 6 s of t dt. Or sorry, not 0 to 6, 0 to t. And if it's been 6 hours, we'll plug in 6, and if it's been 4 hours, we'll plug in 4, and however much time it's been, whatever, we'll just plug that thing in, and we'll integrate from 0 to 4 if it's been 4 hours, 0 to 10 if it's been 10 hours. It just doesn't matter. Small, weird little thing that's easy to make a mistake on. This letter and this letter / this letter have to be different. So if we want to call it y of t, and t is the time, and we're going to integrate from 0 to that time, we just need to change this letter to like an x. Or really just anything. That can stay a t. But these letters have to be different, otherwise you wind up integrating a constant function every time. Now, since these two integrals have the same limits of integration, you might find it easier to rewrite the y of t function as 2,500 plus 0 to t of s of x minus r of x dx, and just merge them as one just big integral. I just like the s one first because it's positive and the r one second because it's negative. So if you want to write it as two separate integrals, you might find that a little easier. But that's pretty much it for part B, which is kind of weird. Part C then asks you, find the rate at which the total amount of sand on the beach is changing at time t equals 4. So for C, you basically want y prime of t, and then we're just going to plug in 4. So based on the FTC, the derivative of 2,500 is nothing, And the derivative of a function like this, like accumulator function type thing, is going to be s of t minus r of t, which should just kind of make sense intuitively. How much is what is the rate of change of the amount of sand on the beach? The amount, or the rate that we're gaining sand minus the rate that we're losing sand. These are just rates. So you might have just thought to start here anyway, just intuitively, and not think of it as like a process where you're taking the derivative of this thing, but it's just the rate that sand gets removed is negative and the rate that sand gets added is positive, and we're just going to put them in. We're going to plug in 4 here, and whatever you get, you get. And I'm getting negative 1.909 cubic yards per hour. So that must mean we're losing sand because the rate is negative, that the tide is removing sand faster than the whatever thing they're using to add sand is putting it back. And then there's a part D, which is for times between 0 and 6. At what time is the sand on the beach a minimum, and then what is that minimum value? So we basically are looking for the minimum amount of sand, which means kind of erase some work that was actually good. We want to know when y prime of t is equal to 0, since y was telling us the amount of sand. So we want to know when s of t minus r of t is equal to 0. So my recommendation is to type this function into the calculator. Just basically make it 15t over 1 plus 3t minus 2 plus 5 sine of 4 pi t, or I guess you have to type in x's in the calculator instead. Also, just be careful here. If you're subtracting the whole r of t function, that has 2 pieces, so you need to be subtracting all of this, and we want to know when this is 0. I recommend changing your, 1, solving this in the calculator, 2, changing your viewing window to be between 0 and 6, and what you should get is a graph that sort of looks something like this. So there's only one place that it's 0. But you can also see that the derivative of this function is negative and then positive. So we're decreasing and then increasing. So that means this is the min. We're good to go. We just need to know what this value is. And what you should be getting from the calculator, if you watch that video for how to do this in the calculator, is 5.118. It's not just asking you what value of t produces the min, it's asking you to find that min. So we need to plug in 5.118 back into that y of t function we made in part B. So y of 5.118 should be 2500 that we started with, plus the integral from 0 to 5.118 of the s of x function minus the r of x function dx. And when I did this, I got 2492.369. 2492.369 cubic yards. I kind of ran out of room to write this answer, but how do I know that this is the min? Well, I know it's the min because the derivative is changing from negative to positive. Do I have to check the endpoints? No. The endpoints are not possibilities. It's not like we went down, up, and then went down again, and then we stopped, and that place we stopped going down could be a min. There's only one contender for the min. They're not the endpoints. We ruled them out by making our sign chart. So alternatively, you could plug in 0, plug in 6, and plug in this number, and which one of those one is the smallest is the min, but you actually don't even have to do any of that because there was only one possibility for the min. We're able to rule out the endpoints with our little sign chart. So that's it for the 4th page, old AP question, done. Week 6 videos, if you're watching them in order, done. And you should be able to do these like homework type things office hours. Come by if you have questions, but that's it for videos for this week.